All right, I think we're going to go ahead and get started here. Looks like we have everybody we're going to have for today. I see some familiar names out there, so thank you everybody for attending. The latest in our Lab Chart Mastery series. Today we're going to be talking about the new HRV 2.0 module. It's been introduced with Lab Chart 8, and there's been a lot of changes in there, both the way HRV works as well as the later analysis further down the way with the module. So we'll be talking about that today. My name is David Ream. I'm the Technical Support Engineer for AD Instruments North America, or one of two, I should say. I actually now have a colleague, Emily Peace, out in our Boston office. So for those of you out there on the East Coast, Emily's available from 8:30 to 5 Eastern Standard Time. So before we get started with our topic today, first I want to go over a few things. First is the webinar guidelines. Those of you who have attended webinars before know all about this, but for any new people, all audio from attendees will be muted during the presentation. That's both to keep background noise down, as well as to keep us on track with what we want to cover today. The primary way to communicate with me is via the GoToWebinar toolbar. If you're on a Mac, you'll see the picture over here on the left-hand side is what your bar will look like, and if you're on a Windows machine, it'll be on the right-hand side. So if you have any questions during my presentation, go ahead and type them here into the questions bar or the chat bar, but the questions usually work out the best, and I will answer them in turn after I've completed the webinar. So definitely once I'm done going through the software and how to do different things, by all means stay and we can talk about any questions you may have. Also, before we get going, I want to talk about some of our upcoming training events. So I will actually be conducting a lab chart training course, levels 1 through 3, here at our Colorado Springs, Colorado location on the 29th and 30th of January. So if you haven't signed up, by all means sign up. I'd love to see you out here. And these courses are designed to take you from a complete novice and get you to a good, solid intermediate user. So, and also there's a little bit of one-on-one time for you as well. We can talk about your specific applications. We're going to be holding another Levels 1 through 3 course out in Boston, Massachusetts on the 26th and 27th of February. So if you, a little bit easier for you as far as travel concerns go, by all means come to the Boston course, which is taught by my colleague Emily Peace. If you have any questions about any upcoming events, please go to our website. And under events, you'll see a list for both North America as well as for the rest of the world, as with upcoming webinars, training courses such as this, what trade shows we'll be at, et cetera, et cetera. Also, please follow us on your social network of choice. If you want to know the latest and greatest about AD Instruments and where we're going, by all means add us here, where we have a presence on YouTube. There's some great instructional videos there. We have a presence on Facebook, LinkedIn, and also we Twitter, and have a Google Plus account as well. So please check in on us and learn about everything that we're doing. Also, I have a little bit of boilerplate here to take care of, just kind of general statements in response to some really, really common questions for tech support here at AD Instruments. And the first one here, you don't have to read all of this, but the take-home message is that no product supplied by AD Instruments is intended to be used to diagnose, treat, or monitor a human subject. They cannot be used for clinical diagnosis or monitoring. They can be used for clinical research, but by no means should we be using a power lab and the associated hardware to actually treat a patient. Of course, after saying that we can connect to humans, there comes the question, okay, how do I know what device I buy from AD Instruments can be connected to a human being? We use the industry standard for the body protected and cardiac protected symbols and their certifications. So if you have any doubts about that, definitely look at the front of the unit, and if it's okay to be connected to a human being, you'll have your little body protected symbol here. And if it's okay to have a direct electrical connection to the heart, you'll have your cardiac protected symbol here. As of right now, I think we don't have any cardiac protected devices. If we do, I can't remember if the blood pressure amplifier's approval is still good or if we've updated it, but that would be the only unit that I can think of off the top of my head that would be approved for cardiac protection. Also, I have a lot of people ask me in different ways, how do I know what's being put into the front of the Power Lab or my other AD Instruments device is accurately being displayed in the software? What I'm seeing is really what's coming into it. We've spent much time and expense getting Quality Management System ISO 9001 certified, and basically they come in, they evaluate our design, our manufacturing, sale, and servicing departments to see that we're doing things appropriately according to what is laid out for other medical device manufacturers. That our testing and validation design, what's going in is what is being reproduced and being displayed. So if you need this for some sort of laboratory approval, by all means we can supply this to you. There's a copy of our certification on our website. So if you can find it there, go ahead and download it and then give it to whoever your review board may be. Or if you can't find it, definitely give myself or Emily a call or your sales rep, and we'll be able to supply you with the certificate. So thankfully, that takes us to the end of our little spiel there at the beginning. And we're going to go ahead and move on to our webinar program for today. As I mentioned at the start, we're going to be covering the new features as well as the basic uses of the HRV 2.0 module that's available for LabChart 8. To get access to that, you have to be on LabChart 8. It will not work with LabChart 7. And first I'll kind of go over a module overview, then we'll kind of talk about setting up the module, what's new in it as far as how it detects the QRS complexes and how it actually performs the calculations. Then we'll talk about the analysis, and finally some new channel calculations that have been added, as well as some of our old favorites from the previous versions that were available in the datapad. So, HRV, what is it? What do we use it for? HRV analysis is a popular non-invasive tool for assessing cardiac health and, of course, the state of the autonomic nervous system. It is thought to reflect the heart's ability to adapt to changing circumstances, and such as unpredictable stimuli, so hot, cold, stresses to an individual. And it's also really useful for investigating the interplay between the parasympathetic and sympathetic nervous systems and their controls on the heart. With the HRV module, going from the previous 1 point whatever versions to 2.0, we've changed a lot to reflect what has happened since we released the 1.0 version of the HRV module. There's been some changes in how calculations are made, how things are identified or defined, and we just pretty much moved the HRV module up to what the current research is. So, and last but not least, the HRV 2.0 module was one of our first cross-platform modules for Mac and Windows. It will look exactly the same in Mac as it does in Windows, and the analysis will be performed exactly the same. Those dual OS users out there, I know you've experienced the frustration of going back and forth between Windows and Apple, and to try to figure out, what works going back and forth, file formats, all that stuff. With LabChart 8, we're putting those issues to bed finally. I know we've been promising it for a long time, and the HRV 2.0 module was the first one that has that nice cross-platform feel, and your analysis is going to be able to move back and forth, and the way you do your analysis will be able to move back and forth. So we're very excited about this. So without further ado, we'll go ahead and we'll go into LabChart 8. So simple file here that I'm going to use throughout our webinar. I have a finger pulse recorded on channel 1 and an ECG recorded on channel 3 here, it looks like. Yep, 3. So normally I like to use ECG for analysis just because of the sharpness of the signal, and it's kind of a little bit more resistant to movement artifact than, say, if something like a finger pulse would be. So throughout this webinar today, I'm going to be using the ECG channel. So module setup, we'll start talking about that. You'll notice, just like before, we have our HRV menu up here in the menu list, and we also, in the toolbar, is populated with a few HRV shortcut icons here, so we can get to our settings here, the new beat classifier view, the report view, the various analysis plots that are going to be available to us, and also tell LabChart whether we want it to analyze or not. So first place we're going to go to kind of talk about what we're going to do, we're going to go to the settings. We've done a lot in the settings here, and of course, like I said, I can get it from here or from out here on the actual toolbar icon. So those of you who have been using HRV for a while, this is going to look pretty different, actually. It's moving more into line what you see in our other modules. And the first real big thing we've done is we've removed the old detection feature of the HRV module, where it would just use a simple threshold or peak after threshold, gave you a few filtering options to take care of any sort of drift or anything like that. And to be honest, it was probably a little clunky compared to some of our other modules. So we've gone ahead and updated and given you a much better detection algorithm to find those QRS complexes consistently and to take care of any sort of noise or drift that may be in there. So basically what we've done is we've actually gone and used our cyclic measurements detection algorithm and applied it to HRV. So just like before, we can go ahead, we can choose our data source. Do I want to look at the finger pulse? Do I want to look at the ECG? We're going to look at the ECG today. Do I want to do the whole channel, or do I want to do selection? Whatever we want to do. And however the beat detection is done, we've actually entered in a fairly wide range here of presets for specific animal models. So human, large dog, small dog, rodents in here, just to kind of give you an idea of, or just to make it a little more automated and use what's already available in cyclic measurements to make it easier on you and get to a good proper detection. Now, if these presets do not work for a particular subject in your test group or for your particular model very well, you still have a custom option available here. So if the presets, I go down here and select custom, I can actually go over here and I have an activated advanced button here. If I left click this, if you're a user of LabChart for a while, you'll recognize this exact view from cyclic measurements, kind of a preview of how LabChart is detecting, and with an overlay of what it's using to detect over the top of the raw data. So the green trace here is our raw data. This black trace is the template that LabChart is using to detect those beats. Of course, we have all our controls that are available out there in the chart view as well as in the cyclic measurement settings windows. I can overlay or stack the detection template with the raw data. I can overlay, I can just look at the raw data. And of course, we are normalizing here or auto leveling. So if there is some sort of oscillation in the baseline, we're going to automatically be being taken care of that. And also our detection is going to be in standard deviations instead of just a simple millivolt or volt threshold that you would normally see in the old HRV module. We can also add some noise thresholds here. Tell LabChart, okay, well, our typical QRS width is this. If it's less than this or more than this, ignore it. Our minimum periods, if we have a little bit of noise, we can use these to tune that out. And also apply a low-pass filter as well, so that we're finding those R waves and dropping our marker right at them like we should. So if you're familiar with some of the things in the old HRV module with the R wave detector, much more streamlined, much cleaner here. And like I said, you'll get much better results as well. And of course, I'm going to give a plug to our technical writers here. Throughout a LabChart, you'll see these little question mark buttons, and this will take you straight to the HRV help for the specific window. So if you're curious about what these exactly do or how they could best be used, definitely click here. So we're going to talk about them today a little bit, but not at you know, we're busy people. We have a lot on our minds. You won't always remember everything that you've heard here in the webinar. So definitely a nice shortcut for you when it's 8 o'clock at night and you're trying to get the analysis done and don't quite remember what one thing does. So like I said, we do have a nice customized option as well, in addition to the simpler presets. Moving down, we have some new analysis options. So for our histogram views, we can choose the bin width here, or we can choose auto, which will give us a bin width, a best estimate by LabChart what the proper bin width should be. So if you don't want LabChart to calculate it, you can just uncheck it. If you do, you can go ahead and check it here. LabChart will make the bin width as it feels as appropriate so that you can see all your data and everything gets laid out nicely. PRR threshold. What does this mean? It is used to calculate the percentage of RR intervals longer than a specific value, or X, which is this millisecond number here we're inputting. Default is 50 milliseconds, but usually the PR threshold is commonly set at 50 to 20 milliseconds. This will show up in your report here. The PR threshold is one of the values that the HRV module is going to actually calculate for you. What to use here, whatever works best for you. Like I said, the range is usually between 50 to 20. Default is 50, but if you want to use a different value, by all means, go ahead. Next, we have the SDAR, or standard deviation average for RR intervals. We could choose the averaging window that we're going to use. 300 seconds is default. And this value is often used to kind of assess a variability over long-term recordings and is influenced by physical activity, changes in posture, or the circadian rhythm, so awake, sleep, stuff like that. And of course, just like we could in our earlier versions of HRV, I can exclude ectopic beats that we don't consider to be of a normal variation. If we do this, they will not be included in analysis. If we leave it unchecked, they will be included in our analysis and our report values. Of course, since we talk about ectopic and normal, that moves us on to our beat classification. In HRV 2.0, we've gotten much more, I guess we could say we removed some complexity from it. There used to be artifact, ectopic, normal. We had, I think, about four different interval ranges we could set, different colors, stuff like that. We've actually just kind of stripped it down to reflect the current state of HRV analysis to normal or ectopic. Something that's varying as we think it should, something that's outside of that may be noise or it may be valid, and it will give us the ability to kind of call those out by excluding from analysis or to include them if we think that they're actually valid. So with that, we've added something we call complexity. That's also referred as form factor in some circles, and it takes into account the shape of the waveform and how it compares to a quote-unquote normal waveform. The greater amount of variation in the signal, the higher the complexity of the signal will be. So typically ectopic beats that just don't quite follow along with a normal-looking ECG like what we're seeing here will have a high degree of complexity. The proper values to use here depends. These are the defaults, of course, but if you want to change it to something that works better for your analysis, by all means go ahead. And these actually come into play later on with the new beat classifier view. That's very similar to some of our other classifier view for things like ECG analysis. And of course, we're talking about variation and at certain frequency bands, we're going to talk about spectrum. So right here is just the basic setups for spectrum. We'll talk more about how things have changed once we actually look at the spectrum view. But we can look here and just tell the spectrum view, okay, the max frequency I want to see here is 0.5 hertz. The number of frequencies, so how many different frequencies will it divide that 0.5 up into? 500, we can change that here. Also, what are our thresholds for our different frequency bands? What do I consider to be very low frequency? What do I consider to be low frequency? What do I consider to be high frequency? And for any of you who are just learning HRV, these different bands relate to different, have different meanings of what's going on with the actual analysis. So very low is a little more disputable what it means as far as the variation within it, but it's often considered to represent sympathetic tone, as well as kind of slower humoral, just bodily changes and thermoregulatory effects on the heart rate variability. There's also some findings that in shorter recordings, the very low frequency band is a fair representation of emotions, whether the subject is stressed or not. The low frequency variation is normally considered to be a good indicator of sympathetic activity, and high frequency variation will reflect parasympathetic or vagal tone, and also the respiratory sinus arrhythmia. So when you're looking at HRV, these are the things you're going to be looking at, activity in these different bands, and these are the things that it's believed to and actually through research is shown to actually correlate with, and why we're looking at heart rate variability in the first place. So that kind of takes us to the end of our settings here. And if I hit OK, lab chart goes through and marks all of the beats, and actually to analyze the whole file. You also notice with these markers that they vary in color, and that is according to our RR interval sets, what we set, and also the complexity, where they fall in that range. And we'll talk about the colors here in a second. So if I go to HRV, we've got our various windows that show up here. So the first thing I'm going to go to, and this is a new feature, is the beat classifier view. And this is where those colors, and I'm going to go ahead and smart tile here. And this is where those colors kind of come from. So the y-axis here is our complexity, and the x-axis is our intervals here that we consider normal. Everything inside of this box is considered normal and will be colored blue, both out here as well as in this block, in this box. Little x's, each x here corresponds to a specific beat. Now these are synced to the chart view, so if I click on one in here, you'll notice down at the bottom here, I will actually move to that beat in the chart view. The same will happen vice versa. And also, if I left click and hold on a marker, I can see this HRV beat, it occurred at this time. This is the RR interval that's being calculated, and this is the form factor or complexity of that and where it falls. Is it normal? Is it ectopic? So if I go out to one of these yellow ones, it moves me in the chart view to it. I click on it, and it tells me it's ectopic. Now the color coding. As I said, blue means normal. Orange means the RR interval falls outside of what we defined as good here with this red box and our complexity and RR interval criteria. So it's fine on complexity, but it's outside of the variation that we would expect. Pink would mean that complexity is where it's falling outside of. So we would have, say, an X up here. It's within what we've approved as a good RR interval, but it could be noise because it's more complex than what we're seeing here, than what we want to see. So it doesn't look like a good ECG wave, but it's around the right interval from the previous one. Red will mean it's outside of both, so we would have an X over here. Let me go ahead and we'll do some drawing here. We would have an X over here. This would mean a red X and a red dot out here in the chart view because it's outside of the complexity limits we've set, 1 to 1.5, and it's outside of the R intervals we set. And if it appears here, it's going to be pink because it's within our R interval, but it's outside of our complexity. And of course, we have some ones that are within the complexity limits, but they're outside the R interval, and they'll of course be orange. So a little bit easier way to kind of tell what's going on. Also, we've decreased the amount of criteria. We no longer have that artifact option that we used to have. Of course, I can change those parameters here if I want to. I can mouse over this box and change its size. Zoom in here a little bit. So you can see now that we have some pink. And of course, just like out in the chart view, all of my options are available here to move the y-axis around. So now I have some pink ones that are outside. Where are some of those? Here we go. Now say I've gone through here and I determine this just is not what I wanted. Just like the ECG analysis module, we have an option to say, okay, consider all identified beats as being good. They meet criteria. So if I go to HRV, I say classify all beats as normal. Lab chart will redraw that box, and also in the settings, we'll change these. Of course, we can come back in here and go to 1.1, 800, 1200, and change things back to how they were. And you'll see our box will change. Oop, a little bit too much. Looks like I missed a, oops. And we're back to where we were with the default. So as I said, good ways we can actually classify things, change how they are. And of course, HRV is unchecked. If we click on this, classify all beats as normal, it'll be checked, and we'll classify them all as being normal. And I'm going to go back and change things here in the settings. And we will put it back to where it was. So ways for us that weren't present before, we can actually go in and move things around and change. And you have a good graphical representation of where things lie and what we don't want to be in the analysis. As I said, if they end up being a topic, doesn't matter how they end up being a topic, we can exclude them from analysis if we want to. So that takes us through the beat classifier view. Next is the report view. We've done a bunch of work here as well. Compared to the old HRV report, much cleaner, much more concise, easier to see what's showing up here. So we can go through here and say, okay, when did our analysis start? What are the total number of beats that are there? Included normal beats, included ectopic beats. What are the different values we're pulling out? So average of the standard deviation of the RR interval, according to the averaging we have it set up here. What are the powers for the different bands? What are their peaks? What's a LF HF ratio? Pretty common. SD, SW1 we'll talk about later when we talk about the point care plot. What percentage of the RR intervals are over 50 milliseconds? Right here. So everything we didn't know. And like I said, we've kind of made some changes here, just number one, for ease of use. Number two, just to make things align more with what's current in HRV analysis. Of course, we can print this HRV report by going to File, Print HRV Report. We can also copy the HRV report as an image and paste it into other programs such as PowerPoint or Excel. We'll talk about the analysis plots in a little bit. There's a lot going on there, so I want to be able to cover them in more depths. But we'll move on and just kind of talk about the various other features here that are a little bit more brief. So I'm going to go ahead and make the chart view larger here. And if anybody has used the actual older HRV software, adding beats and deleting them was definitely possible before, but we've made it much easier and just generally a better process to actually go through and add a beat marker or delete short artifacts. So first things first, if I say find that lab chart is not doing a good job of finding a beat in this region, I've tried tweaking the detection settings and nothing's working, and it's maybe a one or two occurrences that this happens, I can go in here and add an R wave marker by myself. So we're going to pretend that this T wave here is the R wave that we're missing. So I go in here and put my cursor by left-clicking on the chart view at the point where I think the R wave should be. And I go to Add Beat Marker. And LabChart adds a new one. It's green because it's to show me that, yes, it is an added one. That's different than the rest of these. It auto-detected these. And this will be included in the analysis. Now, say, well, I entered that in error, or a few of these are entered in error. I don't want them to be added. I can highlight the region they're in. I can go back to HRV, and you'll see now that I have this delete beat marker option selected. If I just move the active point, like a point selection, or even have the active point in the chart view, that will be grayed out. But to remove this, I select it, I go to HRV, I say delete beat marker, and we're back to where we should be. Also, if I reaccomplish the HRV analysis, it will get rid of those manual adds as well. Now, to save that stuff, I would actually encourage you to use the Analysis Manager in LabChart. I won't talk about it today, but we do have a variety of webinars that discuss its use and how you can save specific settings for unique analysis within a file for a different region, stuff like that. You can do that with the Analysis Manager. So that takes us through adding beat markers and removing them. And this, like I said, this was improved in HRV 2.0. For those of you who use our software for other things, all this will look very familiar for how it comes from the other analysis lists. Do I want to see beat markers? Maybe I don't. I can left-click that. It's no longer checked. We don't see it here anymore. I actually want to see them. I can go ahead and check it, and the LabChart will draw them again. We talked about this before. Classify all beats as normal. I can also tell HRV to analyze while sampling. This is pretty common in our modules. You can do it offline like this, or while you're recording, especially since we have some channel calculations that I've been adding in here. Maybe you want to monitor how things are changing. You can tell HRV to go ahead and analyze while you're actually collecting the data to kind of get more of a real-time idea of what's changing. Maybe we're trying to evoke a response with a specific stimulus. We can see if maybe we need to up the stimulus strength to actually get it to work. We can kind of monitor it in real time. That's what analyze while sampling will provide you. I can reselect analyze data, say I'm analyzing specific sections, and I've moved my cursor around, but I want to make that selection again. I can do that here. I can clear the analysis, and I can analyze the whole channel. If I had this set to analyze selection, it would say analyze selection instead of analyze channel. So pretty common. All of our other modules use the same type of template to go ahead and perform the analysis and actually just manipulate things while you're using it. So that kind of takes us to the end of the list here. And next we're going to talk about the individual analysis plots. So the first we come to, I do a little smart tile here, is the tachogram. Basically we're graphing the RR interval to the interval number here on the x-axis. So just like I said, it's just a plot of successive RR intervals against their specific interval number. What is it good for? The tachogram shows the instantaneous variation in heart rate, and it can be kind of a good identification of misidentified R waves, as they'll appear as sudden dips. These are probably okay, but if you have this huge spike that is extremely small, goes to extremely small RR interval here, or a really large one, you might want to go ahead and take a look at your detection to see what's going on. You may have to tweak your detection settings or actually delete a marker there to make things align and to do proper analysis. Also, you can get to the list from here. So next, RR histogram plot. What are the RR intervals, and what are the most common ones? This is also where we can control that bin count, so how wide these columns are, whether they go from 1050 to 1060, or maybe they go 1050 to 1055 millisecond RR interval. What are the most common variations? What's the most common common one we see here, or most common interval that we see. We'll lay it out in here. Kind of give us an idea of where things are falling. Next, delta RR interval. This is displays a histogram that displays the differences between successive RR intervals. So say one interval, I'm just going to pick a number out of the air here, is 10, and the next one is 15. It'll actually measure, it's talking about the difference between the two intervals, and it'll put their plot here. How do things change? What is the most common change between two successive RR intervals? And then we come to the Poincare plot. The current RR interval graphed to the next RR interval. The spread of the data in this plot kind of provides information regarding the nature of the RR interval fluctuations. And in the Poincare plot, you'll see here we have this ellipse that is being drawn here in a center point. What that relates to is the standard deviation. And of course, the center point here is the mean. So this ellipse is the standard deviation from the average, and how all of these different intervals change accordingly, or where they fall within it. There's also two lines now. These are actually drawn, and I'm going to go ahead and do a little drawing of my own. So this one right here, and this one right here, these are actually new to HRV 2.0, and they're known as SD1 and SD2. So this one right here is SD1, and it's actually the short axis of our ellipse here. What does it mean? What does that do for us? SD1 is related to the fast beat-to-beat variability. So the closer a beat lies to this line, the smaller the change in RR interval from one beat to the next. And if an RR interval is longer than the preceding interval, this indicates a slowing of the heart rate. And also if it's shorter than the preceding interval, heart rate has increased. So pretty clear. Like I said, the closer we are to that, the faster, or the smaller the change from one beat to the next, the farther away, the longer. And of course, we have our SD2 here, and how things relate to that is more related to long-term variation, how things are changing over hours versus seconds, or minutes versus seconds. So that's the Poincare plot. As I said, the spread kind of provides information regarding the nature of the interval fluctuations, how things are changing from one to the other. Last but not least, we come to spectrum, the power spectrum. For those of you who are users for the previous versions, definitely looks a little bit different. We still have the lines drawn as we did before for the different bands, but we've actually provided you some color coordination now, what's very low frequency, high frequency. We can, of course, control the dividers here in our settings window, but we can also go in here and drag them around if we'd like with the mouse. And basically all I'm doing here is I'm mousing over the top of it, left-clicking and holding, and dragging once I have that double arrow. When I go back the other way, I just need to grab a line for that previous version. So I can even put areas between. They don't have to be right up on top of each other. I can actually have just kind of dead space that isn't being considered any of the frequency bands. And just went and drug and butted them up against each other. Regarding spectrum, we've done a big change here as well. We no longer use the fast Fourier transform to calculate this. With current research, there's been a shift, and that shift is to use the LOM periodogram algorithm instead of fast Fourier transform. The new method it's more appropriate for HRV analysis. It doesn't require an evenly sampled data set and is pretty unaffected by the presence of ectopic beats, so give you a little bit cleaner data, a little better analysis. So like I said, we've moved from fast Fourier transform over to the long periodogram algorithm for calculating the spectrum plot. Of course, I can go edit, I can copy the HRV power spectrum plot. I can print it as well. Same thing with all of our views that we saw here, and actually most views in modules and LabChart. So one kind of new thing, I'm going to go ahead and add a channel here. Just right-click here and hit Add Channel. We've actually have some HRV channel calculations that have changed a bit here. So once again, to get there, I can go to the channel drop-down menu or channel calculation menu, left-click on the title to get that, and I have an HRV option here. We can actually graph these as a data trace in a channel, the beat period, the change in beat period, the beat rate, and the beat complexity. You'll also notice we have this checkbox for set guidelines. Guidelines were a new feature in some of the later versions of LabChart 7 that allow us to put kind of a graphical indicator out in the chart view to say, okay, we're above a certain threshold or below a certain threshold. So one that will probably be really good here will be complexity. Or excuse me, beat period, I think. And I'm going to leave the guidelines set here. I'll hit OK. Let's go ahead and smart tile this guy, or auto scale, excuse me. You can see here, whenever we're in, so we have a normal beat or a normal RR interval, we're fine. But once we get out of it, we go into the red region saying, okay, the guideline's telling us we're ectopic across these. Then we're normal, then we're normal, then we're ectopic, then we're normal. Just kind of give us a good graphical view of what's going on. Maybe where we have noise going on there. We want to see what's going on while we're recording. One way we can do this. But like I said, we can go in here, click that, hit OK, and it doesn't appear there. So if you don't want that, by all means, turn it off. If you determine at a later time that you do, you can go back in here and turn it on. And those thresholds relate to what we've set here in the settings, the beat classification, the R interval, as well as the complexity. And of course, I'm going to give another plug to our technical writers. We have that help menu button here that takes you to the exact help menu topic for this window and tells you how to use it, what all of this means. And of course, we can just go ahead and turn it off if we want to. You would also be able to get there via the channel settings. So I'm going to go to Setup, Channel Settings, go to the Calculation column here, and we can set up HRV there as well. So kind of the two ways we can get to that channel calculations menu for a specific channel, either through the channel settings, which is under Setup, or by left-clicking on the channel title. And we get our channel calculations menu will pop up here. Of course, if you've been a long-time user of HRV, you will know that there are HRV calculations in the datapad. So the datapad is kind of a version of software similar to Excel that lives within LabChart. And if I can go ahead, I can access it a few different ways. I can go to the datapad icon here, or I can actually go to Window Datapad as well. So basically a spreadsheet that functions in a similar nature to Excel. I can actually go in here and left click and set up, there's an HRV topic here. So the left hand side here will be kind of overarching topics, cyclic measurements, statistics, etc. If we click on that, it gives us kind of our subtopics, things we can calculate in that column that relate to a specific overarching analysis like HRV or cyclic measurements. So as you can see, a lot of what you have out here in the report view can also be displayed here as well as a spreadsheet. Total number of beats. Okay. And of course, every time we click on one, you're going to see, it'll give you a description of what's going on here. What's percentage of our intervals over a specific time? We can add those here. If I hit Smart Tile, I can see both. We select the whole channel in Lab Chart. We have them right there. Not sure why these are other ones are showing up, but we can just keep going through here in HRV and determining those. And of course, Lab Chart's going to give you a title. And we're not stuck here with just things for HRV. Of course, when I get asked about all the time, how do I pull out the ratio of low frequency to high frequency? Power, right there. Of course, if I wanted to find a median, I could here, a specific channel. Oop. Lab Chart didn't like that, or my Vista software did not like that. Let me go ahead and pull that open again. Sorry about that. Lab Chart recovered it for us. Unfortunately, lost some of our analysis here, but we can go back in and just take care of it. And of course, there's a few other things we can do here as well. So, like I said, things that were there before in HRV 1 point whatever, available here in the data pad as they always have been, with a few tweaks here with changing of some of the calculated parameters to kind of update it to the current HRV analysis. So this brings us to the end of my presentation today. So as I promised, we'll go ahead here and move back to my presentation. If you have any questions, if you think of something after we go offline here,